Hello everyone. This video is about Unit 5 of the course CS3251 Programming in C. I am R. Bhavani, working as Associate Professor in Government College of Engineering, Srirangam, Sedurapatti, Trichy. Unit 5 discusses about these concepts, that is files, types of file processing, sequential access, random access, sequential access file, random access file, command line arguments. So this is the syllabus in the Unit 5, and here in this video we are going to discuss about introduction to files, types of files, sequential access files. So before getting deep into the file processing, we should know what is a file. A file is a repository of data that is stored in the permanent storage media, mainly in the secondary memory. So to have a permanent storage of our information, we need the file concepts. The files are used for storing information that can be processed by the programs. So we not only the information, the programs are also stored in the files, so that we can use the same program again to process our input and get the appropriate output. So what we are going to learn? So we should know how to write information to the file and how to read information from the file. So our C program is going to do this two things mainly. So streams, this is a new concept in C where it is a logical interface to various devices that comprises the computer. So in its most common form, a stream is a logical interface to a file. So it is like as a buffer, right? As defined by C, the term file can refer to a disk file, the screen, the keyboard, a port, a file on a tape, and so on. The stream provides a consistent interface to the programmer. So it acts as the interface between the program and the file systems. So when we say stream I by O, it uses a temporary storage like a buffer, right? So what is read from this permanent storage will be moved to this temporary storage, which is called as a buffer, and this here in C language we call that as streams. A stream is linked to a file while using a open operation. So whenever we want to perform an operation on a file, we have to open that file first. So whenever we open a file, the stream will get linked to a file. When will it get disassociated? It will get associated while we are closing the operation, right? The current location, also referred as the current position, is the location in the file where the next file access will occur. So when we are processing the file, so when we say it is current location, the current location where the file pointer is, so that we call it as the current location, right? There are two types of streams. One is text stream and another one is binary. A text file can be thought of as a stream of characters. Any alphanumeric characters, special characters can be there. That can be processed sequentially. It is going to get processed sequentially, not randomly, right? It can only be processed in the forward direction, right? So while we start from the beginning of the file, we have to move forward to process the complete file. As text streams are associated with text files, they may contain a sequence of lines. Each line contains 0 or more characters and ends with one or more characters that specify the end of the line. So when we read a book, we will be using a full stop to represent the end of the sentence. Likewise here, to denote the end of a line, we may use some end of the line characters to specify that this is the end of the line. A maximum number of characters in each line is limited to 255 characters. So each line could have a maximum of 255 characters. Next is the binary stream. Binary file is a collection of bytes. In C, a byte and a character are equivalent. It is not equal, it is equivalent. Hence, the binary file is also referred to as a character stream. But there are two differences. The null and the end of line character have no special significance and are treated like any other byte of the data. So while we are using binary stream, this null character and end of file character have no special significance, and the interpretation of the file is left to the programmer. C places no construct on the file and it may be read from or written to in any manner chosen by the programmer. Next, how we are going to process the file. As I said already, we have two types. One is sequential access and another one is random access. When we say sequential access, we will start from the beginning of the file and we will move forward till the end of the file to access the content in it. Whereas in random access file, we may start from any location in the file and we may move forward or backward and access the file. So this is the thing about sequential access and random access. Okay, so the four essential actions that should be carried out in sequential access files are: first one is declaration of file pointer variable. Next, we have to appropriately open the file. Next, we can do any processing in the file, and then we have to properly close the file. Next, so the first step is to declare a file pointer. So there are a number of different files may be used in a program. So a program may need more number of files to be opened. So for each and every file, we have to associate with the file pointer. So when reading or writing, the file that is to be used must be specified. So how we are going to do this? We are going to use a variable which is of file pointer type, right? So this pointer variable, it points to a structure file. So here comes the declaration of it, this one, right? So we are going to, in normal declaration, we will use a data type followed by the variable name, right? Likewise here, since file is a structure type, we are using file and then we are specifying the pointer variable to that file, right? So this file structure is declared in the stdio.h file, and each file that is to be opened, we have to assign a pointer to it. Okay, so how we are going to do? The example is given below, where we have file, the file name, that is the structure of the file, and then the file pointer, right? So this star IFP is for one file and star OFP for another file, right? So either we can do it in separate lines or we can simply use a single line statement like file followed by the first variable, pointer variable, and the second pointer variable. Next is opening a file, right? So the first step, we have declared the file pointer, and the next step is to open the file. So we are going to use the fopen statement, right? So this prototype of the fopen statement is, the return type is the structure variable, and this is the fopen function. It takes two parameters. One is the file name and another one is the mode, right? So the first parameter is the file name that we are going to open, and the second is the mode that we are going to open, right? So the file name in a C program can also contain the path information, right? So the path specifies the drive and or the directory where the file is located. So the complete path will be like that, right? That is, if we have a file in our C directory, then it will have C, then followed by colon, then a slash, and then the file name, right? So the complete path specifies the location of the file. If the file name is specified without the path, it will be assumed that the file is located in the current directory where our C program is there. So in that directory itself, our file will be there. So that is the assumption. Next, normally in Windows and DOS, we will be using this / character, right? So this will be used as the separator for denoting the directories, right? So in this example, C : test marks text, right? So these are separated by slashes, right? So this is has a special meaning in C, right? This / has a special meaning in C with respect to escape sequence. So we will be using this double / to differentiate both slash and the / in the path, right? Next, file modes. So there will be two arguments. One is the name of the file and another one is the file mode, right? So the second argument is the file mode. So it is going to say whether we are going to read the file or write the file or append to it, right? So these are the file modes. Only if we say R, if the mode is specified as R, then it is opening the text file. If it is W, then it is creating the text file. If it is A, then it is appending the text file, right? So these are the primary things: read, write and append operation. Next three combinations is for binary file: read binary, write binary, append binary, right? And next is R plus W plus A plus, next three combinations, right? So open a text file for read, write. So this is opened for both read and write. When it is W plus, again it create a text file for read, write. In case if the file is not existing, it will create the file for read and write. And next is append plus. So we can append or create a file for read, write. So both three operations could be done when we use A plus, right? And next is R plus binary, W plus binary and A plus binary. So this is for opening the binary file for read, write, creating the binary file for read, write and appending the binary file for read, write. Here is an example of that statement f open. So initially we have to declare the file pointer. So we have given file and then the file pointer name as *fptr. Next, to that file pointer we are just opening this. So it means that if the file gets opened, the pointer will be assigned to fptr, right? So this is, in this example we are using the fopen function to open the file named marks.txt in the drive test, which is inside the C colon, right? And we are going to use the append mode to open that file. Next, so we have to check the result of fopen, whether the file is opened or not. We should know that, right? So we are going to discuss about that. So if the file is not opened, what will get returned? It will return the null, right? On successful open, it will return the pointer to the structure, right? Okay. So what are the reasons that could be for the failure of opening the file, right? So the last thing discusses about that, the use of invalid file name, right? If the file name is invalid, then it will be not opened, right? Next, attempt to open a file on the disk that is not ready. For example, the drive door is not closed or the disk is not formatted. So these are some issues with the file, right? And attempt to open a file that is not existing in the directory. So we are trying to open in read mode, and if the file is not there in the directory or the drive that we specify, then it will be an unsuccessful open, right? Next, attempt to open a non-existent file in the mode R, right? So these are the reasons which causes failure of fopen. So adding to the example previously discussed, we are checking here in this part whether the file is opened successfully or not. So once this fopen is successful, then fptr will be assigned with the pointer. If it is unsuccessful, then it will return null. We know that, right? So itself we are checking for a condition that fptr is equal to null. If it is equal to null, then we know that the file is not opened. So we just print cannot open the file, and then we are just exiting from the program, right? We are terminating the program. Next, whenever we open anything, we have to properly close it, right? Likewise, here after completing the process on the file, it must be closed properly. So we use fclose function to do that. So the prototype is this. So the return type is int, and then the function name fclose, and then it takes the file pointer. That is the file where the pointer that points to the file that we have to close, right? So when what is the return value? On success, if the closure is success, it returns 0. If there occurs any error in closing, then it returns -1. So this is what it is about closing a file. When a program terminates, all streams are automatically flushed and closed, right? So even if we do not close the file, then automatically it will get closed. But as a good programming practice, we have to properly close all the files that we have opened for operations. Okay, so this is the code which we are appending to the previous example. So the things marked in gray color we have already discussed, right? So after performing all the operations, we have to properly close the file using the fclose function and passing the file pointer that we are using for opening the file. So using this fopen, we open the file and assign it to fptr. So in case if we want to close this file, then we are passing that pointer variable here. Next is fcloseAll. This function is used to close all the files that is in existence, right? All open streams except the standard ones, that is standard in, standard out, standard print, standard error and standard X, can also be closed by using the fclose function. So except the things that is marked inside the parenthesis, all the files that are opened can be closed using the fcloseAll. So it does not take any parameters, so it is mentioned as void here, and the return type is int. So 0 means if it returns a 0, then it is success. If it is -1, it means error. Next is about flush and flush all, right? A stream buffer can be flushed out without closing it by using the flush or flush all library functions. Using the flush when a file's buffer is to be returned to disk while still using the file, right? So even we are using the file, but even the buffer, if we have to clear the buffer, then we use flush, right? Okay, of that particular file. If we want to clear all the buffers, then we use flush all, right? So flush is for flushing out the particular file, and flush all is to flush out all the buffers. So these are the prototypes of it. So here again the return type is integer, and flush, it takes the file pointer, right? And flush all, the return type is int, and there is no parameters for it. Okay, again since the return type is integer, 0 means success or end of file if that is -1, or if an error occurs, right? That's all for about this basic introduction to files. So far what we have discussed is about the sequential file access. So how we are going to open a file, how we are going to close a file. In the next videos we will be discussing about the processing of the files. Thank you.